3 weeks ago, AWS US East 1 region went down, taking the internet with it. We saw a dashboard turning red and support ticket piling up. A panic was spreading fast across the team. Now imagine if you could spin up 3 backup clusters without even knowing there is a problem. Welcome everyone, I'm Netanel from Kaltura, and today I'll share with you how we moved from managing single clusters to automating an entire fleet across clouds, regions, and environment, powered by GitOps. Because here's the problem. If your company wants to expand to 3 new regions, now you need to spin up tens or even hundreds of new clusters ASAP. With manual processes, you are looking at weeks per region at best. And that's if everything goes smoothly. Suddenly, your Q4 project slips into Q1. Or, as I mentioned earlier, a cloud outage hits. Your customers can access your service, and you have no standby clusters ready. You spend hours trying to shift traffic while revenue bleeds. So, you have decided on a multi-cloud strategy to avoid vendor lock-in. Sounds good, right? But now you need AWS, GCP, and Azure. Each has different tooling, different quirks, and now your ops team is burning out. The common issue with all these scenarios? Everything is manual, inconsistent, and painfully slow. That's exactly why we built the GitOps Armada. We created a GitOps-first pipeline that automatically deploys on both clusters, deploys workloads based on cluster attributes, and keeps you DR ready across any cloud, while everything is declarative, traceable, and automated. So what do we need for the GitOps Armada? First, we need to build new clusters. Second, we need to store the cluster credentials and metadata. Next, we need to retrieve the data. And finally, to determine what goes where. Here are the tools we use for the GitOps Armada. Terraform or OpenTofu, a secrets manager like HashiCorp Vault or AWS Secrets Manager, external secrets operator, and Argo CD with application sets. Why do we choose these tools? They are all open source, cloud agnostics, and well supported, making them ideal for a multi-cloud automation framework. Now, I want you to imagine this entire thing like a fleet. Here's how a new ship joins, starting from the left. Step 1, Terraform provisions a new cluster, either on AWS, GCP, Azure, or even bare metal. And step 2, it writes the cluster credentials and metadata into our secrets manager. Step 3, external secrets operator reads the data and syncs it into Kubernetes as labeled secrets that represent the new cluster. Step 4, Argo CD automatically discovers a new cluster. And step 5, application set match the cluster attributes to determine which workload should be deployed. Within minutes, your cluster is live with all the right application. Now let me break down each component and show you what they actually do. Terraform is the ship builder of our Armada. It delivers 2 critical things. First, the cluster itself, the actual Kubernetes infrastructure. Second, and equally important, it writes the cluster identity package into our secrets manager. This includes the cluster credentials and things like the cluster name, region, cloud provider, and environment. This metadata is the foundation that makes everything else possible. Next is external secrets operator, a fleet scout. ESO's job is to read the metadata written by Terraform from a secrets manager. It then creates a Kubernetes secret labeled in a way that tells Argo CD this cluster you should manage, and injects the metadata as additional labels. Finally, Argo CD acts as the fleet admiral. Those labels ESO injected, this is where they become powerful. Argo CD automatically discovers new clusters via those labels. Then, application sets kick in. They watch for clusters with specific attributes and automatically generate Argo CD application with matching attributes. Once those are generated, Argo CD deploys them across the fleet and monitors the sync status. And the best part, Argo CD constantly checks for drift and automatically corrects it. That means our entire fleet stays in the exact state we declare. There are no surprises and no room for error. Now that the fleet is ready, let's talk about how we actually deploy workloads. The pattern is simple. An application set defines deploy X where attribute is Y. That attribute can represent a cloud provider, region, or environment. For example, deploy Carpenter where cloud provider is AWS. When a matching cluster appears, the application set will generate an application for Argo CD to deploy. Now let's see some examples. First example, deploy to all dev clusters in AWS. We are looking for cluster where their environment is AWS, is dev, and cloud provider is AWS. Both conditions must be true. Second example, deploy to all clusters in GCP. A single match label, cloud provider equals GCP. Every GCP cluster will get this deployment, regardless of region or environment. Third example, deploy to all clusters in EU. Here we use match expressions to look at the region attributes. It matches any cluster where its region is in this list. EU Central 1, EU West 1 from AWS, Europe West 1, and Europe West 4 from GCP. Those cluster generators can be mixed with other generators. You can combine cluster generators with Git generators, pull request generators, or any other generator to create sophisticated deployment pattern tailored to your need. Now we'll see the GitOps Armada in action. From the left, Terraform will create a GKE cluster, and on the right, an EKS cluster. Both clusters will have a corresponding secrets in AWS Secrets Manager. We'll let Terraform apply and wait for the clusters to come up. This usually takes between 5 to 10 minutes. For this demo, we'll skip the waiting time. All right, you can see the secrets were created in AWS Secrets Manager, and the external secrets operator pulled them into Argo CD, automatically applying the right labels. Now, the application sets will generate the right applications. The AWS Dev cluster will receive Carpenter and AWS Load Balancer controller. Meanwhile, all clusters will have the guestbook application, syncs in seconds. So, what does this give you? Speed, what used to take weeks, now take minutes. Consistency, zero configuration drift across your entire fleet. True multi-cloud capability, the same pipeline works across AWS, GCP, Azure, and on-prem, and a full control with audit trail. Remember those scenarios we talked about earlier? They are all solved now. This is the power of the GitOps Armada. Thank you.